That looks better. So I'm going to present how you can 3D print your own Wi-Fi-ducky. And I will also explain what that is, of course. For those of you who doesn't know me, my name is Johan from Konow. I'm the R&D manager and heading up the offensive team as well at Sparta Cyber Defense. First of all, to put this in context, you know these hacks that are extraordinary. They are so simple, so beautiful, and you almost get frustrated. Why didn't I think of this myself? They are sort of just takes the whole industry forward. This is not one of those. This is a very simple hack that you can build yourself. It's nothing fancy at all. You most likely have used something similar already. How many of you know what this is? How many of you have used or own a rubber duck? Yeah, that's quite a few. Most of you, actually. So for those of you who doesn't know what it is, it's a USB keyboard emulation that sort of injects scripts, and you can program it to do basically whatever you want. And it's a very popular pen testing tool to show vulnerability at the different clients. So for instance, you can use it to start a calculator, beacon out to a C2 server, inverse some payload that could deliver a reverse shell or something like that. And you could also dump credentials, and my favorite is change the autocorrect settings. So if nobody says you were there, try writing this and see what happens, and then they will realize that you compromised the computer. The Wi-Fi duck is like a rubber duck, but with remote control access. And you can build one yourself if you do it this way. I think it's super hacky, but it's also rather unstable and maybe not so stealthy. So I decided to sort of try to do this a little bit more efficient. But without using a PCB, I actually used a 3D printed part here. And you can see the channels that sort of guides the wires that connect the boards together. So there are two different boards, one for the Wi-Fi and one for the keyboard emulation. And the good thing here is that they cost less than 100 Swedish crowns, so you can just build tons of them and distribute and plug them in everywhere. So nothing to lose. It doesn't take that long to build, but it's a little bit more than 5 minutes. So I made a video to show how the build process is, and it's some fast forwarding. Look, first you connect the devices, you compile the code, you upload it. And when that is done, you can 3D print the casing and also the guiding. And then you have copper wire, and you just route that in the sort of channels that are already prepared. And it's like sewing almost. I just sort of go around here, and all the endpoints are actually now sort of short-circuited. But I cut them open, and then I can assemble the two different boards. So those are then soldered. You just add sort of power, ground, and I2C communication on both boards. And once that is done, you are up and running and can use it. So you connect it to a host computer. It becomes an access point that you connect to. Then that access point set up a web server that you can log into. And that web server contains the script or the payload that you want to deliver. So here I'm uploading and sending it to my own web page. That's it, as simple as that. So it's a quick hack, very easy to do. And you can find all the files and necessary things here. So print it and do something with it and see what you can do. On my site, I also 3D print a lot of other stuff, everything from MIDI synthesizers to our Du Bois clones for Game Boying. One more thing, I think all good speeches should have some freebies. So if you don't have access to a 3D printer, I have some samples here. So let me know, and if you have any questions, approach me or send me an email. Thank you.